Hi again, and welcome to today. We're going to learn about absolute value equations and inequalities. Okay, so let's begin right away. So our introduction says, so this symbol with the two straight up and down lines is the absolute value. And you can say basically it's the distance on a number line from 0. So it's the distance from 0 if you were looking on a number line. So basically here's 0. And whenever we mention distance, we don't ever talk about distance as positive or negative, right? Like if I was going to your house and you were 3 miles away, I wouldn't say I'm going 3 miles. And then when I'm coming home, I wouldn't say now I have to go negative 3 miles. It's still 3 miles. We talk about any kind of distance always in a positive way. So whenever I'm talking about the absolute value of x, I'm basically saying the distance of some value from 0 is 5, and which is why I get plus or minus 5. So I get these two solutions, positive 5 and negative 5. All right, so that's basically what absolute value means. So we're going to use that to think about other things. So now it says we're going to look at solutions to the absolute value of x is less than 0. So exactly what it says here is true. So if it's less than 5, that means it's between -5 and 5. I'll tell you how, I'll show you an example of this so you know how to think about it. But mathematically, it's just saying that if the absolute value or the distance from 0 is less than 5, then in set builder notation, it looks like that. And in interval notation, it looks like that. But let's think about really what it means. Let's say I say that I live, let's do this. So I'm gonna make a number line. And here's, let's say here is, let's just say this is FAU. Okay, I know none of us are at FAU, or at least I'm not because obviously I'm online. But let's say I'm at FAU and you tell me you live less than 5 miles from FAU. So if I call this west and I call this east and I call this 5 miles and I call this 5 miles, and let's say I know you live 5 miles from FAU, but either east or west, like not north or south, because we're not doing a circular range, we're just doing a linear range, right? So does it make sense that I know if you tell me you live less than 5 miles away, that means you're going to live somewhere between here and here, right? That's less than, because I'm not including 5 miles. If I get to 5 miles, if I go east and I go more than 5 miles, it means I've missed your house. Or if I go west from FAU and I go more than 5 miles, it means I've missed your house, right? So basically it's between these two numbers. That's a little different though than if I said I live more than 5 miles, either east or west from FAU. Because now, let's say this is 5 and this is 5 miles, right? Then I don't live 5 miles, but I live more than 5 miles away. And here is west more than 5 miles away. So we can see if we're talking about east and west and distance, why we're talking about these different intervals. Hopefully that makes sense. Now, on a number line, we only change east and west to positive and negative, so we know which direction we're going, right? So on a number line, this is 0, this is +5, and this is -5. And then I'm going to be going from here to here. That's what the absolute value of 5 means. The same thing I can apply to the second solution. So notice here, I have in set notation, x is either less than -5, because if I put it on a number line, this would be 0, and this would be -5, and this would be +5. So we can see that either it's less than -5 or it's more than -5. And in interval notation, it's from -infinity to -5 to -5. And then it goes from 5 to infinity. But when I have two separate intervals in interval notation, I connect it with this U for union. Okay, so hopefully that'll make things a little easier. Okay, so the properties of absolute value are, if we have an algebraic expression, then the absolute value of U equals C means that U is either positive or negative C, because remember it's 5, or it's C units from, so if we're looking at equals, we know it's, if this is 0 and this is C and this is negative C, we know that it's going to be either here or here, because I have this equals, right? So it's not an interval, it's just two values. If the absolute value is less than C, well, here's 0, and here's C, and here's negative C. Now, what I'm going to do is, when we say less than, we're not including the endpoints, remember? So we're not including either one of these endpoints. So we have open circles. And since it's smaller than that C, it has to lie between these two values, right? And again, for the last one, it's going to lie outside of those two values because it's bigger or greater than. So it would be from here out and from here down. Okay, so those are the three different ways that we're gonna see absolute value inequalities. Now, whenever we want to solve something, the first thing we want to do is we want to get rid of the absolute value sign. So how do I get rid of the absolute value? Well, the absolute value means that whatever's inside of it is either positive. So I'm always going to have this one equation where this is positive, or else I have what's inside that absolute value is negative. Because if I put absolute values around here, right, it turns whatever that value is into a positive value. So I'm going to say this is also equal to 4. And a lot of you've probably learned it where you would say this and this are equal. So that's the same as multiplying both sides by a negative, and I get 1 minus x equals -4. So basically, again, I have what's inside those parentheses is either equal to +4 or -4. Okay, so I just solve it now. So I have 1 minus x equals 4. And I add 1 to both, I subtract 1 from both sides. I get -x equals 3. Now I could either multiply or divide by -1. Let's just divide by -1. And if I do that, if it was an inequality, I would flip the sign. But since it's an equality, I don't flip anything. I just make this x equals -3. So I have one solution, x equals -3. And then I do the same thing for my other equation. And now we're saying that that could equal -4. So again, I do exactly the same thing. And I get -x is equal to -5. I divide both sides by -1, which gives me x equals positive 5. So those are my two solutions. Well, let's just check and make sure I didn't make any mistakes, okay? So let's plug in our values. We have, for the first one, we have 1 minus -3, which is the same as 1 plus 3, which is the same as, I know these absolute values are getting mixed up with my ones right here. I'll do this. Which equals the absolute value of 4, which equals 4. Right? Which is what we said. So perfect, that checks out. And now let's put in 5. So I have, I'll do this in a different color. So I have now the absolute value of 1 minus 5, right? And make this one a 1, that, which equals the absolute value of -4. And the absolute value of -4 is 4. So again, that also checks out. So we have our two solutions that are x equals -3 and x equals 5, and they both solve this equation. So now we want to talk about inequalities. And again, inequalities are a little more difficult to do with absolute values. So I'll try to go slowly. Again, if you have any questions, please feel free to come, ask me for help, or go to the Math Learning Center, or talk to Sarah. One of us can help you, whoever you feel would be the most, you feel the most comfortable with. So I'm going to solve. First thing I do is I pretend like that's a parentheses, like the 4x minus 3 is inside the absolute value, so that's on its own. So the first thing I'm going to do is I'm going to take care of whatever's outside of the absolute value. So I now have the absolute value of 4x minus 3 is less than or equal to 5. Okay, and now again, I have my two solutions. I have either 4x minus 3. Let me see how I want to say this. So, okay, well, yeah, let's just do it the same way. So I have two different solutions, right? Either what's inside here is positive, which would give me 4x minus 3 is less than or equal to 5, or I have this other solution where negative 4x minus 3 is less than or equal to 5. I'm showing it to you like this so you can understand what my next step is, because I'm going to turn this, for ease, I'm going to divide both sides by -1, and I'm going to say this is the same as 4x minus 3. And if I divide both sides by -1, remember what I have to do. I have to flip my inequality sign, and I get -5. So here's the two equations that I have to solve to find the two values of x. Okay, so let's do the first one. So we have 4x minus 3 is less than or equal to 5. I add 3 to both sides. I'm not going to show every step. If I add 3 to both sides, I get 8. If I divide both sides now by 4, I get x is less than or equal to 2. And now we'll do the other side, which is 4x minus 3 is greater than or equal to -5. Again, I add 3 to both sides, which gives me 4x is greater than or equal. And if I add 3, I get -2. Divide both sides by 4, and I get x is greater than or equal to -2/4, which is the same as -1/2. So I now have my two solutions, okay? And we know that this particular 4x minus 3, because it's less than 5, so I'm looking right here. So because this is less than or equal to 5, Remember what that means. If it's the distance from 0, so let's say this is 0 and this is 5. And let's do this. Let me do a little better job. 1, 2, 3, 4, 5. -1, -2, -3. That's enough, right? So I know that the distance of that equation from 0 is between -5 and +5. If I were to graph this, let me see how to say this. So if I were to graph the absolute value of 4x minus 3 is less than 5 on a number line, I would say it has to be, because it's less than or equal, we can put, we're closed on both ends. And that means the distance from 0 is smaller than 5. So it's got to be between these two values, right? So now I know all I'm going to do here is change the outside values, but it's still coming between the two of them. Okay? So I know x is less than or equal to 2. So I can put a closed dot here. And then it's greater than or equal to -1/2. And I'll say -1/2 is right about there. And it still includes -1/2. And now I know it's between that x. This is the absolute value of 4x minus 3. And now this is just where x is. And we don't even have, I don't even have to say the absolute value. I can just say 4x minus 3 is between those two values for that number line. And notice it changes for just x because we solved it. And it moves it around and it becomes between -1/2. So this is -1/2. And this is +2. So anyway, that's how that works. Hopefully it makes sense.